Direct current is the unidirectional flow of electric charge. Direct current is produced by sources such as batteries, thermocouples, solar cells, and commutator-type electric machines of the dynamo type. Direct current may flow in a conductor such as a wire, but can also flow through semiconductors, insulators, or even through a vacuum as in electron or ion beams. The electric current flows in a constant direction, distinguishing it from alternating current. A term formerly used for direct current was galvanic current. The abbreviations AC and DC are often used to mean simply alternating and direct, as when they modify current or voltage. Direct current may be obtained from an alternating current supply by use of a current switching arrangement called a rectifier, which contains electronic elements or electromechanical elements that allow current to flow only in one direction. Direct current may be made into alternating current with an inverter or a motor generator set. The first commercial electric power transmission used direct current. Because of the significant advantages of alternating current over direct current in transforming and transmission, electric power distribution is nearly all alternating current today. In the mid-1950s, high-voltage direct current transmission was developed, and is now an option instead of long-distance high-voltage alternating current systems. For long-distance underseas cables, this is the only technically feasible option. For applications requiring direct current, such as third-rail power systems, alternating current is distributed to a substation, which utilizes a rectifier to convert the power to direct current. See war of currents. Direct current is used to charge batteries, and in nearly all electronic systems, as the power supply. Very large quantities of direct current power are used in production of aluminum and other electrochemical processes. Direct current is used for some railway propulsion, especially in urban areas. High-voltage direct current is used to transmit large amounts of power from remote generation sites or to interconnect alternating current power grids. Various definitions. The term DC is used to refer to power systems that use only one polarity of voltage or current, and to refer to the constant, zero frequency, or slowly varying local mean value of a voltage or current. For example, the voltage across a DC voltage source is constant as is the current through a DC current source. The DC solution of an electric circuit is the solution where all voltages and currents are constant. It can be shown that any stationary voltage or current waveform can be decomposed into a sum of a DC component and a zero meantime varying component. The DC component is defined to be the expected value, or the average value of the voltage or current over all time. Although DC stands for direct current, DC often refers to constant polarity. Under this definition, DC voltages can vary in time, as seen in the raw output of a rectifier or the fluctuating voice signal on a telephone line. Some forms of DC have almost no variations in voltage, but may still have variations in output power and current. Circuits. A direct current circuit is an electrical circuit that consists of any combination of constant voltage sources, constant current sources, and resistors. In this case, the circuit voltages and currents are independent of time. A particular circuit voltage or current does not depend on the past value of any circuit voltage or current. This implies that the system of equations that represent a DC circuit do not involve integrals or derivatives with respect to time. If a capacitor or inductor is added to a DC circuit, the resulting circuit is not, strictly speaking, a DC circuit. However, most such circuits have a DC solution. This solution gives the circuit voltages and currents when the circuit is in DC steady state. Such a circuit is represented by a system of differential equations. The solution to these equations usually contain a time-varying or transient part as well as constant or steady-state part. It is this steady-state part that is the DC solution. There are some circuits that do not have a DC solution. Two simple examples are a constant current source connected to a capacitor and a constant voltage source connected to an inductor. In electronics, It is common to refer to a circuit that is powered by a DC voltage source such as a battery or the output of a DC power supply as a DC circuit, even though what is meant is that the circuit is DC powered. Applications: direct current installations usually have different types of sockets, connectors, switches, and fixtures, mostly due to the low voltages used, from those suitable for alternating current. It is usually important with a direct current appliance not to reverse polarity unless the device has a diode bridge to correct for this. The Unicode code point for the direct current symbol, found in the miscellaneous technical block, is U+2393. DC is commonly found in many extra low voltage applications and some low voltage applications, especially where these are powered by batteries, which can produce only DC, or solar power systems, since solar cells can produce only DC. Most automotive applications use DC, although the alternator is an AC device which uses a rectifier to produce DC. Most electronic circuits require a DC power supply. Applications using fuel cells also produce only DC. The vast majority of automotive applications use 12-volt DC power. A few have a 6V or a 42V electrical system. Light aircraft electrical systems are typically 12V or 28V. Through the use of a DC-DC converter, high DC voltages such as 48V to 72V DC can be stepped down to 36V, 24V, 18V, 12V or 5V to supply different loads. In a telecommunications system operating at 48V DC, it is generally more efficient to step voltage down to 12V to 24V DC with a DC-DC converter and power equipment loads directly at their native DC input voltages versus operating a 48V DC to 120V AC inverter to provide power to equipment. Many telephones connect to a twisted pair of wires, and use a bias T to internally separate the AC component of the voltage between the two wires from the DC component of the voltage between the two wires. Telephone exchange communication equipment, such as DSL-AM, uses standard a 48V DC power supply. The negative polarity is achieved by grounding the positive terminal of power supply system in the battery bank. This is done to prevent electrolysis depositions. See also: electric current, high voltage direct current power transmission. Alternating current, DC offset, neutral direct current telegraph system, references. External links: AC-DC, what's the difference? DC and AC supplies. ITACAA,